In this video, I will explain you the failure of wave theory. Okay. As per wave theory, we have learned that from a source, the light will be propagated three-dimensionally as a wavefront. For example, we have a point source. Now, from the point source, light will be propagated in the shape of sphere. These spherical shapes are called as wavefront. So these wavefront will be propagated. Okay, so this is the light source, this is the wavefront. 1, 2, 3. In this way, wavefront will be propagated three-dimensionally across the light source. Now we will see these 3 points which explains that wave theory is a failure. First point is energy of light is not proportional to amplitude or intensity. As per wave theory, we have learned that energy is proportional. Energy of the light ray is proportional to the intensity, okay, or amplitude. This we have learned as per wave theory. But in photoelectric emission, we have seen a graph in this way. When we have changed intensity, we have seen that there is increment in photoelectric current. The reason is higher the intensity, more amount of charge carriers or electrons will be emitted out from the emitter. So on incident with photon, more number of charge carriers will be emitted, and that is the reason for higher photoelectric current. But how to check the energy of the electron ejected? By checking the stopping potential. Now with all the intensity, it is the same stopping potential for a material, which means that irrespective of the intensity, the maximum kinetic energy of an emitted electron is the same. With all the intensity, it is the same, and energy is a function of frequency, and we have learned that E is equal to h nu. Now higher is the frequency, higher will be the energy. Now we have to give a different stopping potential, and the graph was in this way. With lower frequency, the graph, this was the stopping potential. I was able to stop photoelectric emission by giving a reverse potential in this way. But when I have increased the value of frequency, now I have to apply this much reverse potential to stop the process. So this was the graph. So energy is a function of frequency, but as per wave theory, it is proportional to amplitude and intensity, which has proven wrong with the theory of photoelectric emission. Next thing, with wave front, many electrons should come together, but it doesn't happen in this way. For example, this is the wave front. Now I am keeping a metallic sheet here. Now what will happen? This wavefront is carrying the energy, right? Now see, I have a metallic surface in this way, a wavefront is coming, and this wavefront will give energy to all the electron. Now this energy is not sufficient. Say for example, it is not sufficient to come out of that metallic surface. Now what will happen? Next wavefront will come and will load more energy. So initially 5 joule, let's say the work function is maybe 20 joule. Now initially a wavefront will come and give 5 joule to all the electrons, and one more will come and give more 5 joule. Now it is 10 joule, then 15 joule, then 20 joule. So once that becomes equal to the energy that is required, minimum energy that is required to come out, that is work function, all the electron will all electrons will comes together at a stretch. So what will happen? In that case, there will be a time lag. So initially there won't be any photoelectric emission. On loading the wavefront on the metallic surface, the energy will be increased and photoelectric emission will happen. But actually, is it happening in this way? No. The moment we are turning on the bulb, we are able to see a photoelectric emission happening in this circuit. How we are able to see? By measuring current. So photoelectric emission, if it is happening, there will be a current in the circuit. So with wavefront, if this is a wavefront, what will happen? All the electrons will get energy. So this will get accumulated over again and again, and all the electrons will be coming out at one stretch together. So it is not happening in this way. So with wavefront, many electrons should come together, but it doesn't happen in that way. And next thing is, now as per wavefront, all frequencies should be able to do photoelectric emission as per wave theory, because whatever may be the frequency, with that frequency, that will load energy after exposure for a longer time. For example, now the frequency, that threshold frequency is equal to frequency of violet, blue, green, yellow, orange, red. Let's say threshold frequency is equal to frequency of yellow color light. Now we know that only yellow will be able to do photoelectric emission with that material. Yellow is able to make it, even blue is able to make it, indigo is able to make it, violet is able to make it. All these are having frequency equal to threshold frequency or more than threshold frequency. See, blue, indigo and violet are having more than threshold frequency, and yellow is having equal to the threshold frequency. But red color bulb, if you are keeping it years and years and years, that will not do any kind of photoelectric emission, because red color is less than threshold frequency. Now whatever may be the time of exposure, photoelectric emission will not happen with red color light. But with wavefront it should happen with wave theory. But as per photoelectric theory, it is not happening, which means that wave theory is no more valid. Next thing is, see, there should be a time lag between radiation and ejection of electron. Now as per wave theory, wavefront will come and give certain amount of energy. This will accept it. Now next exposure, next wavefront will come, more energy is given. Next will come. So this energy will keep on building one after another, and at certain point that will come out. So there is a time lag. So I am switching on the bulb. I am waiting for the electron to accumulate the minimum amount of energy required for photoelectric emission, and after that this process will happen. But is it happening in that way? No, there is no time lag. What does it mean? The moment photon comes, so photon is not a wavefront, that will move in a way bullet is moving. So a bullet will come and will hit with the electron, and that is able to take electron from a metallic surface. Okay, so there is no time lag. Now opposite of this will be the theory of photoelectric emission. So I can tell you the postulate. One thing is, with intensity Y, first question can be, with intensity Y there is an increase in photoelectric current. See, photoelectric current is increased over intensity. The reason is, intensity means more number of radiation. Now initially less number of radiation, when incident on a surface, lesser number of electrons are came out. Now more number of radiation means more number of electrons are coming out. But what will happen to the energy of electron? That will not change. Energy will be the same, but more number of electrons have came out. Now with frequency, what is happening? Higher the frequency, now that will give more amount of kinetic energy for that ejected electron. So basically energy or kinetic energy of ejected electron is a function of frequency. Okay, and next thing is, there is no time lag in between radiation and photoelectric emission. That will instantaneously happen. This is instantaneous, radiation and photoelectric emission. Okay, yeah, that's all. Thank you.